you will notice that the postulate sheet is stapled, is longer than normal, just because there's a lot of little postulates that are in this chapter. Overall, though, most of them are very, very simple ones. Most of them are going to tell you things are congruent, or they're going to tell you things are supplementary. It's just a matter of what they are. Now, on your postulate sheet, I have things broken up by shape. Today we're just going to talk about some properties of polygons in general, but eventually we're going to talk about parallelograms, and here's all the parallelogram stuff. Rectangles, rhombi, squares, kites, and trapezoids, and isosceles trapezoids. So, the postulate sheet makes this chapter look scarier than what it is. Open up to the first page of your notes. Today we're going to start talking about polygons. A polygon is a shape that is enclosed by 3 or more line segments. Triangles are polygons, squares are polygons, rectangles are polygons. The key thing is that these sides are straight and it is enclosed. Now, polygons come in 2 forms. There's concave polygons and convex polygons. Concave means it's kind of like caved in. It's got these indents in the shape. Convex means there's no indents. All of the vertices go outwards. So these are convex polygons. If it's got any sort of curve whatsoever, it's not a polygon. Now with our polygons today, one of the things we're going to be talking about is something known as a diagonal. A diagonal of a polygon connects one corner or one vertex of the polygon to another vertex that's not right next to it already. So it's not already connected by a side of the shape. Going like from here to here, for example, would be a diagonal. You don't have to draw that diagonal in. So when it comes to our polygons, up until 12 sides, they all have specific names to them. Some of them you absolutely know. For example, a 3-sided polygon, a shape that's got 3 sides, is a triangle. You know that one. Now, when you have a triangle, if this is my triangle, it is impossible for me to draw in any diagonals. There's no diagonals in a triangle. Therefore, when I draw in my diagonals that are not there, I create one triangle, and therefore the interior angles of the triangle add up to what again? 108. As the shapes get bigger, the interior angle sum is going to increase, and we're going to look for a pattern. 4-sided polygon. Think you know the name of that one? A square is an example of one. Rectangle is an example of one. Parallelogram is an example of one. Starts with a Q. Quadrilateral. Good job, Noah. Most of this chapter we're going to be focusing in on these quadrilaterals. Now if I draw in all of the diagonals coming off of one corner of a quadrilateral, so let's say I come off of this corner, it only gets one diagonal. And if I draw in that diagonal, how many triangles are formed? 2. And if one triangle's angles add up to 180, what do 2 triangles add up to? 360. What about a 5-sided polygon? pentagon. And if I draw in all the diagonals, starting from one vertex, I'm going to start from the one on top. I get a diagonal here and a diagonal here. And you get 3 triangles. And therefore the triangle angle sum, way too big.
Way too big. Agreed.
Obtuse does not make sense for an answer. How would you find it?
180 times 3.
You do 180 times 3.
That's like 1,000.
It's not that big. Y'all gonna want a calculator today. Grab a calculator if you don't have one. But they add up to 540.
So that's the thing. I knew it.
Anyway.
You got a fancy calculator.
Hey y'all, I need your attention back. Anyway, are you starting to see a pattern?
Yes.
A triangle has one triangle and angles 180. Quadrilateral will end up with 2 and 360. A pentagon will end up with 3 and 540. What do you think a 6-sided polygon is going to end up with for number of triangles? 4. And so to get the interior angle sum, we would do 4 times 180. Essentially, what ends up happening is, let's say a polygon has n sides. How do you compare the number of triangles to the number of sides? Three sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. Minus 2. So you take the number of sides and you'd subtract 2 from it. So if it's n-sided, it's n minus 2. And you multiply that by 180 to get the interior angle sum. And that's going to be something we talk about a little bit more on the next page. But that's going to be the pattern we use. Before we get there, let's name the rest of our rest of our polygons, I should say. 6-sided polygon, hexagon. 7-sided people don't tend to know very well. Any guesses? What was that?
Heptagon?
Yes, heptagon.
Octave.
8-sided?
Yeah,
Octagon. 9-sided? Yep. Nonagon.
These are actual real things.
Hmm?
These are real things.
Yes, these are actual things. 10-sided? Decagon.
Oh, it does it.
11-sided is a hendecagon. And 12-sided is a dodecagon.
No, I knew it was something like that. What was that?
They've got presentations next door.
Oh my gosh.
As the number of sides gets larger than 12, they no longer have a specific name. They just call it an n, where n is the number of sides, and so it would actually be a number, dash, gon. So if it's got like 30 sides, they call it a 30gon.
How do you know all this?
I know lots of things. So, today we're going to be working with the polygon interior angle sum theorem that says the interior angles of a polygon will add up to, in parentheses, n minus 2 times 180, where n, because of this, is the number of sides. That is how you find the interior angle sum of any polygon, regardless of how many sides it has. You just need to know the number of sides. For example, this one right here, how many sides does it have? 6. It's a hexagon. So n equals 6, and you plug 6 into your formula. 6 minus 2 times 180. If I want to simplify that, what should I do first?
Do negative 2 times 180.
Nope. 6 minus 2 first. Parentheses first. 4 times 180. What is 4 times 180? Is that a calculator? 720 degrees. Now, note, that is the interior angle sum, meaning that's what the angles add up to. That is not what each individual angle is. There's also nothing guaranteeing that all the angles are the same. Just like in triangles, you can have different angles. So, one of the things you'll be asked to do is find the sum of the measures of the interior angles for the following shapes. And it'll start with something like a decagon. To do this, you got to start by knowing how many sides a decagon has.
Well, how will we know that?
You've got an entire sheet that tells you the names of them and how many sides they have. A decagon has how many? 10.
Oh, yeah.
It's on the front page of your notes. And it's 10. Therefore, we plug into the formula. Parentheses, 10 minus 2 times 180. What part of that do we do first again? 10 minus 2, and we get 8. 8 times 180? 1,440. 1440. That's what the 10 angles of the decagon should add up to. Nonagon. N is 9. Once I figure out how many sides it has, what do I do with it?
It's 1,000.
What do I do?
Oh, you do?
Plug it in.
Yeah, plug it in.
Subtract 2, and then multiply by 180. 9 minus 2 is 7. 7 times 180? 1260. How many sides does a 23gon have? 23. And you do the same thing.
This one is 3.
This one's going to be very big.
Yeah, 3,780.
3,780 indeed. The more sides, the bigger the angle sum. So that's one of the things you're going to see today. Pretty easy start. The other thing you're going to see today is going to be similar to things we did in last chapter. And it's problems like these ones, where I give you the interior angles as expressions. Some of them you'll know as straight numbers, some of them you won't. When we ended up with triangles that had shapes like this, what did we do? We added them all up and set it equal to 180, but why was it 180? Because that's what triangle angles sum to. That's not a triangle. It's not a trapezoid. What is this shape?
Which one?
It's a quadrilateral. In other words, being a quadrilateral tells you it's got 4 sides. And if it has 4 sides, how can you figure out what the angles are going to add up to? If only there was a formula for the polygon's interior angle sums. I got a formula for it. Now, is it going to be 360? Yeah, you're right on this one. That's one we actually calculated already. But if you didn't know that, this is how you would figure it out. You plug into our formula, you get 2 times 180, and you get 360. Therefore, all 4 of those angles, because if it's got 4 sides, it's going to have 4 angles. That's how polygons work. The number of sides and the number of angles are going to be equal. So if it's got 4 sides, you plug into this, that's what the angles are going to add up to. So now I can write my formula. Now, one common thing that I see people do is they write this. Where did I make my mistake? I didn't remember the 90. Remember, just because it doesn't say a number doesn't mean it isn't a number. You should know that that shape, that little symbol, means 90 degrees. Y'all trust my solving skills? X is 55. Is that what the question asks me to solve? Read the instructions, find the value of X, and then each interior angle. Now this one's really easy. What's that interior angle? That's the only one we were missing. 55. But make sure you're plugging back in. And make sure you're telling me which angle's which, if it's not obvious. This one didn't have names for them, the other ones will. Okay, problem B. The key thing to look at is, where are these angles? Where are these measurements sometimes? Because sometimes the measurements aren't going to be angles. Are these angles? Yes. Are they inside the shape or outside the shape? Inside the shape. And you've got all of them. What are they going to add up to? Where are you getting 540 from? On this one you can from the front page, because how many sides does this one have? 5. Now that is one that's on the front page, but if it wasn't, we would do this formula. And 3 times 180 is indeed 540. When you do this, a common mistake I see made is this. On a problem like this one. Stay with us. What did I do? When there's multiple angles of the same thing, people often forget one. I highly recommend you, first off, you start at one corner and go around either clockwise or counterclockwise. That way you make sure you get all of them. Or you put a little dot by them as you get them. Another common mistake I see is this. Is that supposed to be a 4? No, it's supposed to be a 14. I want to solve this equation. What do I have to do at this point? Combine like terms. 3x plus 2x plus 2x plus 3x is 10x. 14 plus 142 plus 14 is 170. Subtract the 170 from both sides, and I get 370. Divide by 10, and x is 37. Is that what the question asked me to do? Partially. It wanted me to solve for x, but what else did it want me to do? Find each interior angle. Obviously not the one you already know. H and K are both 2x, which means the measure of angle H is 2 times 37. 74. Measure of angle H is 74. Measure of angle K is equal to 74. M and L are both 3x plus 14. Plug back into them as well. 3 times 37 plus 14. Y'all got calculators. You don't have to do it in your head. Is 125. Measure angle M is 125. Measure of angle L is 125. We got one final problem, and we're not going to do the entire thing. We're just going to talk about the setup of the last one. The measurements you know. The things you got to look at in this chapter. Are they sides? Are they angles? They are angles. Is it all the angles in the shape? Yes. If it's all the angles, you ask what they add up to. How many sides does this shape have? 1, 2, 3, 4, 5, 6, 7. What's its name? Heptagon for a 7.
What?
How do I figure out what the angles add up to again?
Because it's
7 minus 2 in parentheses times 180.
so 7 times 5.
Comes 5 times 180, which is 900. And so you would simply say 4x plus 2x minus 5 plus 2x plus 3x plus 2x plus 4x minus 5 plus x plus 10 equals 900. And then you would solve. We're going to stop right there.
Good.
Don't ask me what the answer is. I don't know. I haven't solved it yet. How are you feeling about today's stuff?
Where's the
I don't know.
she didn't know.
Yeah, I don't know where Abby is. I don't know if she's here today or not.
I know she's not here because she's gonna be gone all week.
Oh, yeah.
And then she go on vacation.
Forgot about that. She did actually tell me that. So, today we did section 7.1, day 1. Today is the best day of the entire year.
Why is it today's what? Oh, it's your birthday?
It is.
Oh, happy birthday.
Thank you. We are not on a book page. What am I thinking? I got a worksheet for y'all.
Keep going.